Tree diagrams are a really handy way of doing conditional probability. Just a reminder, the conditional probability of B given A is the probability of B happening given that A has happened or happens. If A and B are dependent events, this will be different this will be a different value compared to just the probability of B, whereas in independent events they're exactly the same. The AND rule for dependent events is the probability of A and B is the probability of A multiplied by the probability of B given A. You can also write this with a little line, so we could write probability of A and B is equal to probability of A multiplied by the probability of B, and then given A is a little line, so B given A. You won't really see this at GCSE, but we are technically expected to know it. However, I would suggest at GCSE just to look at the tree diagram sensibly and to use that to evaluate any probabilities. Here's an example of conditional probability with a tree diagram. Sally has some counters in a box. There are 7 red counters and 5 blue counters. She chooses a counter at random from the box, notes its colour, and does not replace it. She then chooses another counter at random from the box and notes its colour. We want to complete the tree diagrams and the questions. The first time she takes a counter from the box, the probability that she chooses a red counter is 7 out of 12, and the probability that she chooses a blue counter is 5 out of 12. Following the red branch, if she chooses a red counter, well, she takes that counter out and does not replace it. So there were only 11 counters left in the box, and because she's taken one of the 7 counters, there's only 6 red counters left as well. This means that there are still 5 blue counters, but there are only 11 counters in the box, so the next probability for blue is 5 11s. Now following the first blue branch, if she takes a blue out of the box, there are only 11 counters left, and there are 7 reds, but now there are only 4 blue counters out of 11 counters. To work out the probability that both counters are red, we want the probability of red and red. So notice now, I'm not really thinking in terms of our dependent events formula, I'm just thinking about it in terms of the tree diagram. This is going to be the probability that I get a red on the first counter multiplied by the probability of red on the second, which, if I follow the tree diagram, just gives me 7 twelfths multiplied by 6 11ths. And to work this out, I can just multiply the top by the top and the bottom by the bottom, giving me 42 over 132. The probability that both counters are blue is going to be 5 twelfths times 4 11ths, which will give us 20 over 132. The probability that both counters are the same colour, well, there are 2 ways this could happen. This is probability of red and red, or blue and blue. Well, the probability of red and red is 42 out of 132, and the probability of both counters being blue is 20 out of 132. And remember, or means plus. This gives us a final answer of 62 out of 132. Finally, the probability that neither counter is the same colour is just 1 minus the probability that both are the same colour. This is just 1 minus 62 over 132. 1 is 132 out of 132, so we have 132 out of 132, take away 62 out of 132. This gives us 70 out of 132. Here's an example with decimals, which you'll quite often see. So in this question, John cycles or drives to work, and this time his choice influences whether or not he is late for work. The probability he cycles to work is 0.4. The probability that he is late, given that he cycled to work, is 0.65. So we can see that is him being late, given that his first means of transport was cycling. The probability he is late given that he drove to work is 0.34. So we can see that is here. To work out the missing branches, I just need to remember that the probabilities at each pair of branches still add up to 1. 0.4 plus 0.6 is 1. 0.65 plus 0.35 is 1. 0.34 plus 0.66 is 1. So those are the missing probabilities. To calculate the probability he cycles and is not late, I need to follow the branches, cycles, and then is not late. Remember, and means multiply, so I need to do 0.4 multiplied by 0.35. 14. The probability he drives and is not late is going to be 0.6 multiplied by 0.66. To be 0.396. Finally, the probability that he is not late, well, there are two ways this is possible. He either cycles and is not late, or he drives and is not late. There's no other possibility. Now, we've worked these probabilities out in A and B, so we just need to do, remembering that or means plus, 0.14 plus 0.396. 36. A question for you to try. Please pause the video now and have a go at it, and when you're ready for the answers, press play. Here are the answers. Remember, you don't need to simplify your final answers. And remember, for the first question, we're not just asking for the probability of red and then blue. We want the probability that she chooses a red and a blue, or a blue and a red. That's what it means to work out the probability that she chooses a red sweet and a blue sweet. Red and then blue, or blue and then red.